Welcome to my YouTube channel, A Brainery of Civil. Today I am going to solve the first assignment of Advanced Concrete Technology. In this assignment, I won't teach much theory. You can understand on your own by reading the content. Okay, I just briefly discuss about questions and answers. I don't want to discuss much theory behind the question. Okay, just I'll give you the question and answers. Okay, ready? Let's start. So first question, the modern clinker when compared against aspirin clinker has dash amount alite and dash amount belite sized particles. So that is, the question is comparison between clinker that we are using now and the clinker that was invented at the starting. Okay, so in modern clinker and aspirin clinker. In modern clinker, generally nowadays, we should have strength of concrete in latter stages, not early strength. Early strength is because of more heat of hydration. Okay, so we want the strength of concrete in latter stages, that is after complete construction of few days. Okay, so generally alite is C3S compound and belite is C2S compound, and here C3S, C2S. In olden days, that is in aspirin clinker, this C3S is more and C2S is less. That is, they were interested to have more strength in the early times. But now, after realization, it is better to have strength in latter stages. That is, belite should be more and alite should be smaller compound. Okay, so here it is smaller and it is bigger. So the answer is B for question number A. Okay. Next question. The manufacturing process of calcium aluminate clinker gets completed within the kiln. So whether the statement given was true or false. Obviously, this is a true statement. Generally, if you observe, there are 4 zones in kiln. So the first zone is dehydration zone. In this dehydration zone, the temperature is ranging from 450 to 800 degrees centigrade. And the next zone is calcination zone. So 800 to 1350 degrees centigrade. And clinkering zone, it is 1350 to 1550 degrees centigrade. And finally cooling zone. Okay, so here the temperatures again decreases. So now calcium aluminate, the compounds related to calcium aluminate are C3A and C4AF. All these compounds manufacturing completed in kiln itself. In kiln itself. Okay, so the statement given is right. Next question. Match the following. Temperature at which reactions occur. Okay, so if you observe this, I'll write this less than 900 degrees centigrade. So that is in the first one, in the match, left side match, decarbonation of CaCO3 will take place. CaCO3. So that is 1, it is D. And 900 to 1200 degrees centigrade. So formation of C2S will take place. And greater than 1250, formation of C3S will take place. And here 900 to 1200, formation of C2S will take place. That is 2B. And formation of C3S will be, it is 3A. And in the final stage, final cooling stage, Both. Remaining, what are all the compounds after C2S and after C3S? Remaining are formation of C3A and C4AF. Okay, so for in cooling stage, both C3 and C4AF will form. That is 4, it is C. So the answer is C for question number 3. Clear? So this is most theory topic. So you need to remember all the values. In which range of temperature there is a formation of dicalcium aluminate, tricalcium aluminate, tetracalcium aluminoferrate. So something like C3S, C2S, all these compounds. Okay. Next question. In optical microscopy, the white or bright spots in the image represents which phase? So in this, for example, this is a concrete surface. Here there are white patches, something like this. Okay. So something like these patches will occur somewhere. These are all obviously because of tricalcium aluminate. Okay, so these are because of tricalcium aluminate. Answer 3. Option C for question number 4. Next question. This is the most important question, and this generally these are all bogus compounds or box compounds. In ordinary Portland cement, each box compound will constitute how much percentage? The most important question they'll ask directly in the GATE exam. First C3S, majority percentage, nearly half, around 50%. So its range is from 45 to 60%. And C2S, 15 to 30%. C3A, 6 to 12%. And C4AF, it is 6 to 8%. This is also called as elite, belite, selite, pellite. Okay, so it is tricalcium silicate is elite, dicalcium silicate is belite, tricalcium aluminate is selite, tetracalcium aluminoferrite is pellite. So these are all its percentages. Which both compound will constitute how much percentage in cement after reacting the raw compounds with water, these will be formed. Okay, so the question for question number 5, the answer is D. And in the next question, match the crystal structure and different phases. That is, what is the structure of different Bohr compounds? Bohr compound and their structure, very important. First coming to C3S. So its structure is, it is of irregular structure and it will consist of several polymorphs. So structure is irregular structure and it will consist of several polymorphs. And C2S is a rounded structure and it will also consist of several morphs. Coming to C3A, it is cubic in form. It is something like a cubic blocks, cubic in pure form. And coming to C4AF, it is series of solid solutions. Several series of solid solutions will constitute the structure of tetracalcium aluminoferrite. Okay, so for question number 6, it is answer B. These are all very important. So C3S is irregular structure, C2S is a rounded structure, and C3A is cubic structure, and C4AF is, it is series of solid. Okay, it will constitute series of solid. And next question is direct question. Blaine's fineness value So this Blaine's apparatus is useful for fineness. Fineness is generally how much surface area by taking unit weight of cement. Certainly, if we take 1 gram of cement, how much surface area has in this 1 gram? Generally, why the surface area plays the main role in the cement is to get reaction. Reaction will propagate, reaction will start from surface itself. Okay, so that is, if we have many more number of particles in 1 gram, its reaction rate will increases. For example, if you say OPC 33, 43, 53, what is the difference between OPC 33, 43, 53? OPC 33 will have specific surface area is less compared to OPC 43. When OPC 43 having some specific surface area is nothing but surface area per unit weight. Compared to 43, 53 will have more surface area. So that surface area can be calculated by using Blaine's apparatus. Okay, so generally for OPC type of cement, surface area is 300 to 500 meter square per kg, or this will be 3000 to 5000 centimeter square per gram. This value is most important. Answer is C for question number 7. And now question number 8. The type of kiln process that is commonly used in recent times is. So generally the cement is manufactured in two methods. The first method is wet process and second method is dry process. In olden days, they are followed in the manufacturing of cement is a wet process. Now in modern days, they are using it as a dry process. So the kiln that we are using nowadays is dry process kiln. Answer is B. If we use wet process kiln, first of all we need to wet the material and again we need to dry the material. So the energy consumption in the wet process is more compared to dry process. So that's why in modern days the kiln that they were using to prepare cement is dry process kiln. So why we are preferring dry process kiln I explained. Is it okay? And next, question number 9. The formation of box compounds for ordinary Portland cement from the raw materials are completed. Obviously, whenever the raw materials are fed into the kiln, at the end of the kilning process, all this box compound manufactured. Okay, so that is at the end of the kiln itself. Clear? At the end of the kiln, we will get all the box compounds. Clear? Answer is C for question number 9. And question number 10. The molten phase containing C3A and C4AF. So C3A and C4AF from the kiln should be cooled gradually at a low temperature. So generally these aluminate compounds will require rapid cooling. Okay, so these will not constitute the strength of cement. C3S and C2S are more percentages in the cement. They will constitute strength of the compound, but C3A and C4AF will provide heat of hydration more during hydration process. Okay, so for that process, for that application, we need to cool this C3A and C4AF molten phase, these paste at very rapidly. Okay, so this statement is false statement. So 10 answer is false. And finally, the question number 11. Last question. So he has given some raw materials and what is the percentage of their in the right side. So first of all, the largest constituent of cement is lime. So that is lime means CaO. It will be 60 to 67. Next, silica. Silica is nothing but it is a sand. So it is SiO2. It's ranging from 17 to 25%. And then is alumina, Al2O3. So it is ranging from 3 to 8. And iron oxide. So it's ranging from 0.5 to 6%. These values are very important. Okay, lime, silica, alumina, iron, lime, silica, alumina, iron. Okay, so you need to mug up all these values. For question number 11, this is answer is D. So I hope we completed all the questions in assignment 1. Clear? So these are all theory questions. If you read only once or twice, don't mug up at first reading itself. First of all, the way you read is, first of all, just read the statements, read the theory. By reading itself, half of the theory you can able to remember. And in the second reading, whenever what are all the contents that you are not recognized, try to remember them. And in the third reading, everything it will be there on your brain. Okay, so revision is very important for all these type of theory problems or theory questions. Okay, in a single time watch or single time reading, you will get nothing actually. I hope you liked my explanation. If you liked my explanation, you just put comment or like, share it to your friends, and I'll be happy if you share at least one. If you get benefit at least one person. Okay, thank you.